Welcome, everyone. Today, we're diving into the fascinating world of big data and Connectionist AI, brought to you by Team 7. If you ever wondered how AI systems get so smart, like recognizing your voice or suggesting your next favorite movie, this tutorial is for you. We'll explore the data behind the scenes and the neural networks powering AI. Ready to become a big data and AI whiz? Let's get started. First up, what exactly is data? Data is essentially raw facts and figures collected for analysis or decision-making. Think of it as the digital equivalent of puzzle pieces: numbers, text, images, sounds, all waiting to be put together. On its own, data is like a messy room. But when organized and processed, it transforms into useful information, helping us understand problems or make smarter decisions. So, data is the raw material, and when polished, becomes the golden insight AI loves to munch on. Now let's talk big data. Big data refers to extremely large and complex sets of information, so vast that traditional computer systems struggle to handle them. Imagine trying to fit the Library of Congress into your smartphone. Big data feeds AI systems the enormous volumes of information they need to learn, spot patterns, and predict future trends. From weather forecasts to your next favorite playlist. Without big data, AI would be like a detective without clues, utterly lost. Big data is often described using the 4 V's: volume, velocity, variety, and veracity. Volume refers to the immense size of data generated every second, from social media posts to sensor readings. Velocity is about how fast data flows in, streaming in real time, like a fire hose of digital info. Variety means the many forms data can take: text, videos, pictures, you name it. Veracity highlights the importance of authenticity and trustworthiness in data. After all, garbage in means garbage out. Analyzing this data requires powerful tools to find meaningful patterns. So, how do we make sense of all this data? 2 key steps: analysis and visualization. Data analysis scans through data from sensors, social media, and smart devices, finding patterns and relationships that might not be obvious. Data visualization turns those findings into clear charts and graphs. Imagine turning complex numbers into a colorful pie chart or an engaging line graph. It's like turning a novel into a comic book. Together, analysis and visualization form a bridge linking raw data and AI's powerful decisions. Big data operates through 4 main functions. On 1, data collection and cleaning, gathering data from sensors, social media, or databases. Then cleaning it by removing noise and errors, because no AI likes messy data. 2, data processing, converting unstructured data into usable formats. Imagine turning a cluttered desk into neat files. 3, statistical and machine learning analysis, using algorithms to detect trends, patterns, and correlations, where AI really starts flexing its muscles. 4, data visualization, presenting the insights with interactive dashboards and graphs, so humans can understand and act on them easily. This cycle is what powers AI's ability to make smart decisions. Big data's power is truly awe-inspiring and drives multiple real-world applications. AI-driven healthcare. Big data enables AI to analyze medical records and images, predicting diseases early and recommending treatments. It's like having a super smart doctor on call 24/7. Smart cities and IoT. Imagine city traffic lights adjusting in real time based on traffic flow data or detecting when streetlights need repair. That's big data at work. Finance and cybersecurity. Banks use big data to detect fraud instantly and protect your money. Retail and recommendation systems. Ever wondered how Netflix or Amazon seem to read your mind? They use big data to recommend shows, movies, or products tailored just for you. The potential of big data combined with AI is enormous, reshaping industries and lives. With great power comes great responsibility. handling big data ethically is crucial. There are 3 core principles: privacy, fairness, and transparency. We must protect individuals' privacy, make sure data use is fair without bias, and be transparent about how data is used. Global regulations like GDPR in Europe and CCPA in California enforce these principles. Breaking them can lead to hefty fines. Meta got hit with a $1.2 billion penalty in 2023. Ethical big data use builds trust and ensures AI benefits everyone without crossing boundaries. To wrap up big data, harness it responsibly. Think of big data as fuel powering innovation. It empowers insights that drive smarter decisions and better products. And we all must collaborate for an ethical future where AI and big data serve humanity positively. Now, let's switch gears and explore the other half of the story: Connectionist AI. Connectionist AI learns from data through artificial neural networks modeled after the brain's neurons. The star of this show is the Artificial Neural Network, or ANN. It's excellent at pattern recognition, whether that's your speech, handwriting, or images, and can learn and adapt over time. But it's also often called a black box, because even experts sometimes can't fully explain how it makes decisions. Also, it demands significant computing power and careful management to avoid overfitting when it memorizes instead of learning. Think of Anne like a genius apprentice, incredibly skilled, but a little mysterious. Let's break down the basics. A neuron node is the basic processing unit. It receives input, applies weights, and produces an output. Weights are numbers that determine how important each input is, like giving louder voices more attention. Bias is a constant added to shift the neuron's activation, kind of like setting a threshold. Differentiation. The activation function decides if a neuron fires. Imagine it as a gatekeeper with functions like ReLU or sigmoid. Neural networks are organized in layers: an input layer, several hidden layers, and an output layer. Data travels forward from input to output during what's called forward propagation. Learning happens through multiple steps. Forward propagation sends data through the network to get a prediction. The network then calculates loss, how far its prediction is from the actual result, like scoring itself on a test. Backpropagation adjusts the weights and biases to reduce this error, similar to correcting mistakes on a homework assignment. This process repeats many times over numerous examples, gradually improving accuracy. With enough training, the network becomes a reliable prediction machine. Big data fuels Connectionist AI by providing vast amounts of examples to learn from, while Connectionist AI acts as the engine interpreting that data. Without big data, even the smartest neural network is like a car without gas, just sitting there. Together, they create powerful AI applications. There are 4 main types of neural networks you should know. 1. Feed-forward neural networks, FNN. Data flows one way, input to output, no loops. Used in stock market prediction, medical diagnosis, credit scoring, and fraud detection. 2. Recurrent neural networks, RNN. Great for sequential data like language, speech, and music. Variants include LSTM and GRU, which remember information longer. Applications include language modeling, speech recognition, and music generation. 3. Convolutional neural networks, CNN. Specialized for processing images. Famous for image classification, medical imaging, and facial recognition. 4. Transformers. Models like BERT and GPT that revolutionize natural language processing. Advanced with encoder-only, decoder-only, and vision transformers. Each type has strengths, making them suited for different AI challenges. Deep learning is a subset of machine learning using multi-layered neural networks. It's the AI behind systems like ChatGPT, self-driving cars, and facial recognition. It uses depth, many hidden layers, to extract complex features directly from raw data, meaning no tedious manual feature engineering. Thanks to scalability, performance improves with more data and computing power. Think of deep learning as a multi-layered cake of intelligence. Deep learning also includes convolutional and recurrent networks for images and sequences, generative adversarial networks, GANs, where two networks compete to improve, like friendly rivals. To make training efficient and robust, techniques include dropout, randomly dropping neurons during training to prevent overfitting, making the network more general. Batch normalization stabilizes and speeds up learning by normalizing layer inputs. Transfer learning, using pre-trained models to save time and resources. Tier fine-tuning, tailoring pre-trained models on specific data sets for better accuracy. These techniques ensure your neural networks are both powerful and practical. In summary, big data is the fuel, and Connectionist AI is the engine driving modern artificial intelligence. By responsibly harnessing big data and powerful neural networks, we enable incredible innovations while building an ethical, trustworthy AI future. Thanks for joining Team 7 on this journey. Keep nourishing your AI curiosity, and who knows, you might build the next big breakthrough. Thank you for watching. This is Team 7 signing off. Stay curious, stay ethical, and keep exploring the exciting world of big data and AI.